In this module, you'll learn how to distinguish top-down and bottom-up assemblies, create new components, and create external components. To better understand Fusion 360's assembly structure, you should understand the difference between the two assembly approaches. The first and most traditional method is called bottom-up and represents assemblies created from separate design files for each assembly or subassembly. The second method is called top-down, which represents all subassemblies and parts being created in a single design file, resulting in the assembly. In Fusion 360, the term components represents individual parts and subassemblies that make up an assembly file. You can think of components as containers that group all relevant 3D bodies, sketches, construction planes, and other assets related to a part or subassembly. Components are made up of one or more 3D bodies, though they technically could have zero. Meanwhile, Fusion 360 assemblies consist of one or more components. Any Fusion 360 design files can be a single component or an assembly containing multiple components. All Fusion 360 design files start as a single component, as noted by the gray cube icon. Create additional components or insert them into a Fusion 360 design file to turn the file into an assembly. As a general rule and best practice, always create a component as soon as you begin to work on a new file, unless you are modeling a single component. Select New Component in the toolbar to create a new component. By default, all components are a standard component. Components can also be sheet metal components, which include additional information about the sheet metal, including a sheet metal rule. After the type, define whether the component is external or internal. External allows us to create a separate design file when using the bottom-up assembly approach. In contrast, internal allows us to place the new component in your active design file, nested under the active component. We can also name each Fusion 360 component as we create it, as well as change the name at any time via the browser. Because components represent assemblies and subassemblies, it's important to note which component is active in the browser. New components will become nested underneath the active component. If desired, we can clear the parent component and select a different component in the browser. This allows us to choose the location where the component will be nested. Finally, we'll select Activate to keep the component active once created. Let's click OK to see what active looks like. A component is active when it has this active circle icon next to it. Active means all features or operations that we create will display in the parametric timeline of that component. Activating different components and subassemblies will allow you to focus on one aspect of a larger assembly while keeping assembly files organized. It's essential to note that components are required to use joints, which allow you to position and align parts. In Fusion 360, joints cannot be applied directly to 3D bodies. Within an assembly, components have their own origin and coordinate system and can move independently throughout the assembly. Components can be copy and pasted both as same occurrences and new occurrences. This allows you to reuse parts throughout your assembly. Components are also required to add part numbers and properties for bill of materials or BOMs. To create a bottom-up assembly, we can right-click on the file in the Data panel, followed by Insert into Current Design. Notice the inserted component includes a link icon. This lets us know that the component is referencing an external design file. In other words, a Fusion 360 file that is not located within the active file. One of the benefits of a bottom-up assembly approach is that they support distributed design workflows. Multiple people can work on different parts of the assembly design at the same time. They also make it easy to reuse parts of a design in different assemblies. Conversely, a top-down assembly approach allows you to add joints to position parts as you finish designing each individual part. Top-down assemblies enable fully parametric designs and components to share the same set of parameters. It also allows you to organize and centralize your design data across workspaces. Traditionally, one of the downsides to a bottom up assembly is that you would have to open each individual design file to conduct any work, even if it were a simple change. This can become cumbersome, particularly with large assemblies. Fortunately, Fusion 360 offers a great solution through the Edit in Place tool. We can hover over any external component or subassembly and notice the pencil icon that appears. This lets us activate and edit an external component in the context of the assembly without leaving the parent design. When we activate Edit in Place, we can see the component in its real location within the assembly as we edit it. The external component displays in the canvas. Other components in the parent design become inactive. We cannot edit inactive components, but they remain visible in the canvas to give us the full context of the design. We can still measure relative distances or create associative relationships between the geometry of the external component and the inactive components. If we change the size or position of the reference components, the external component we just edited will receive the update as well. In summary, Fusion 360 components are required to create assemblies and subassemblies, including the use of joints to precisely place each part. Fusion 360 is flexible and allows both bottom-up and top-down assembly methods, letting you choose the right approach for your project or team.